All right, so now we're going to start up the review for Chapter 5, the math you need to know for Chapter 5. I think it's helpful to know as a student when you're doing Chapter 5, there is no StatCrunch version to use. This is all calculator math. I mean, like, you can use StatCrunch to do calculator math, but it's like a pain in the ass to describe how to use, and it's just like way longer than using a calculator. So you're better off just using a calculator for it. Some things you'll need to know for Chapter 5 is scientific notation. We have talked about it before, but it does show up. And so we want to do a little bit more with it. And let me give you a couple of good examples. The mass of the sun is 1.989 times 10 to the 30 kilograms. And mass of a dust particle (7.53 times 10 to the negative 10 kilograms. And I'm going to write out the bottom one. We'll look at the top one in a second, but the bottom one's helpful to look at. The negative 10 means, picture a dust particle. It's really small. It doesn't weigh, it doesn't have a lot of mass. It's really small. It's almost zero. So negative numbers means the decimal has to move. The negative 10 says the decimal has to move to the left 10 spaces. I've already got one space right here, which means it needs 9 zeros. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then my 753. That's the equivalent of 7.53 times 10 to the negative 10 kilograms. So that's a big number, and it was really long to write. We use this scientific notation where the numbers are really, 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 really big, or super, 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 super close to zero. And we could put, like, z is that number, and we'll say it's y times 10 to the n. This is my z, it's the actual value. This is my y, and I have 10 to the negative 10. This is my n. Negative 10 is my n. For scientific notation, we always want y, that y right there, to be between 1 and 9, like including those. So like 1 is less than or equal to y, less than or equal to 9. Or another way of saying that is 1 is less than or equal to y, less than 10. Below 10. In fact, I like that version better, because it can be 9.89999. It could be 9 with the decimal. We're going to go with that one. Now, I'm not going to write out all the 30 for the kilogram, the sun. But I think it's worth looking at what happens if you just do a few and go and look at and going, how big is that really going to be? If we look at the mass of the sun, let's just dumb it down a little bit. Let's say instead of 30, let's do like 12. If I had 1.989 times 10 to the 12, this is a big number. It means I need to move this decimal right 12 times. I've already got 3, so I need to move it another 9, which means 9 more zeros. So I would have 1989000000000. That would be times 10 to the 12. This is millions, billions, trillions. Times 10 to the 12th is trillions. And I only did 12. 30 means adding 18 more zeros at the end.
So at the top number, the negative unit, the decimal store, and then it's positive unit.
Yes. So the large, when n is large, if n is like greater than 1 or greater than 0, it's a large thing. And so on the large values, when we're doing it, this direction is going to move to the right. And for n, when n is less than 0, these are for really small values, like the dust. And for those, we move them to the left. N here is an integer. An integer is like -7, -4, -3, 1, 6, like anything, any number without a decimal with it. That's an integer. So I think a handy way of remembering it that's a little simpler is when n is positive, it's a big number. You better end up with a big number. If n is negative, it's a small number. That's a good, straightforward rule of thumb without thinking about directions. You know a big number when you see it. That doesn't, you don't need a left or a right to go, that's a fucking big number. Like, do I want my paycheck to be a big number? Yes. I know what a big paycheck number looks like. Let's do some examples. In fact, let me give you guys a few to try. We'll go over them and then I'll give you a few more to try. Rewrite these without scientific notation. Write these as normal numbers. So anyone still working on it? Okay. So the 10 to the -4, negative is a really small number, so I need a small number, which means I'm going to move it left. I need to move it left 4, and I already have one of them right here, which means I'm going to need 3 more zeros in front of that 5. And 5 is a positive number, which means this is a big number. Big numbers have a bunch of zeros at the end, so I need to move this direction 5. And I already have 2 of them right here, so I need 3 more numbers. I need 3 more zeros added at the end, and I could throw in a comma and we'll get 621,000. That makes sense? Everyone go with that part? What about going the other direction? So that was taking us out of scientific notation. What about going into scientific notation? If you've noticed from everything we've had, all of them have had just a single digit in front of the decimal. You want to end with 1 digit in front of the decimal. 1 digit that's not a 0, I should say, in front of the decimal. That's how we write in scientific notation. So let's give you a chance to write that down, and then try writing these as in scientific notation. Maybe I should walk you through the first set. I want to end up with only 1 number in front of the decimal, means I want the decimal there, which means I need to move it that way 3 steps. If I move it 3 steps to the left, 4,000 was a big number, so that's going to give me a positive exponent. And on this one, I want to end up with just a single number in front of the decimal point. I want it to be right there. I want 2 to be my number in front of the decimal. It means I need to move it that far, and I had to move it 5 times. So this is going to be written as 2.4, and since it was a small number, this is going to be a -5. Does that make sense? All right, let me give you guys one to try. Do that. And then let's go. Yeah, let's write those in scientific notation.
Where's the decimal at on the first one?
It should be after the 1. You always want it at only 1 digit in front of it. Everyone ready? So it is, the decimal starts here. I want it after the 1, which means I gotta move it 8 times. So it's 1.57, and it's a big number, so it's gonna end up as a positive number. Here, in fact, on both of them, I want it after the 1. Here, I need to move it that way, and this was a small number, so small numbers need to end up as negative. This is why I think thinking of it in terms of big and positive is more helpful than in terms of left and right. Because notice up here, when we had the 621,000, we said move it to the right 5. But when we're going the other direction, we start with a big number, I'm moving the decimal to the left. So like saying left and right depends on whether or not we're starting in scientific notation or ending in scientific notation. So left and right changes depending on which way you're going. But if we stick with big and small, that shit stays the same. Associate big with the positive exponents and small with the negative exponents. Then you won't have there's no confusing big and small. I'm big, Maddie's small, right? All right, now let's kick it up a notch. You guys ready to kick it up a notch? What do you mean no? We have to kick it up a notch. Let's do some multiplying and dividing in scientific notation. Okay, so scientific notation always uses this X. You will never see a dot. It's always an X. But in this case, this X is multiply. So this really is 2 times 10 to the third times 7 times 10 to the fourth. And I can wiggle these around. I can put the 7 in front. We talked about the commutative properties of multiplication before. I'm going to switch the order around like that. So I think it's a little easier to see what we're doing here. Hopefully, 2 times 7 is trivial for you. 14. What about this? If you're not sure what to do, write it out as what the number it is. 10 to the third power is 10 times 10 times 10 is 1,000. Like you can put it in the calculator and see what 10 to the third is. And 10 to the fourth is 10,000. So the exponent really tells us like the number of zeros on each one. Well, if I multiply 1,000 times 10,000, I get this, 10 million. So if I move that up and write that in terms of what we're doing up here, 14 times, and again, this is the exponent, the number of zeros. There's 7 there. Is there a relationship between the exponents? And if so, what is it?
You add the 3 and 4.
3 plus 4 equals 7, right? It's exactly the relationship. So this is always true. If we have 10 to some exponent m, and we multiply it by 10 to some exponent n, this is the equivalent as 10 to m plus n. But we're not done with this problem. So I'll bring this down. I've got the 14. Right now we're at 14 times 10 to the 7th power. And we know this, since this is positive, this is a big number, right? Are we agreed? If I multiply by 14, is it getting bigger or smaller? This isn't a trick question. What? If your paycheck was multiplied by 14, would you have more money? It's bigger, right? So the 14 is going to make it bigger. 14 makes it bigger. And that can be helpful because we recall we want to have, right now the decimal is here. And for scientific notation, we want it like that. We want it after the 1. And one way to do this is write the 14 as 1.4 times 10 to the 1. And I still have times 10 to the 7th. Then we can use the rule we used above with the adding the exponents, because the 10s are the same bottom. And I have 1 plus 7 is 8. So that would be the final answer. You don't need to write this step right here with the times 10 to the 1 if you recognize that going from 14 to 1.4 makes this 10 bigger. That was the idea of saying 14 makes it bigger. So if I rewrite it as scientific notation, this should get bigger, which means a bigger number. You guys want to try one? I think you do. Practice, practice, practice. Let's give you 3 times 10 to the 5th power, and then we're going to do 4.1 times 10 to the 7th power, and see what you come up with. Anyone still working on it? Yeah, okay, keep going. All right, let's give it a try. Let's see what we get. So if I do the 3 and the 4.1 together, and then I have the 10 to the 5th and the 10 to the 7th. What did you, actually, let's see what you guys got. Anyone want to share their answer? Be brave. Show some cojones. That doesn't apply to everybody. I don't want Selena showing cojones. I'm not going further until one of you gives me a goddamn number. Someone step up. Be brave. Have just an ounce of faith in yourself. Or if you don't think you finished, say, this is how far I got. Because did anyone finish? No one finished.
I got 1.23 times 10 to the 13th.
1.23 times 10 to the 13th. Thank you, Cody. Did anyone else get that?
Yeah.
Okay, so a couple people got this. Did anyone get something different? And if so, what was it? I saw you shaking your head no.
So 13, I put 12.
So you had 1.23 times 10 to the 12.
Yeah.
Okay. Anyone else have that? Anyone else have something different? All right, let's figure out what we got. So what is 3 times 4.1? What is that value?
12.3.
12.3. And if we do this, what do we have? The 5 and the 7? 12. So we're getting there. But we know we want to have only one decimal point. We want that to be a 1.23. Which means this is multiplied by 12. And so it's getting bigger. Which means my exponent should be going up when I shift it. So if I shift to 1.23 by moving the decimal point left one, This is 1.23 times 10 to the 1, and then I got 10 to the 12. If I add them, I should end up with 1.23 times 10 to the 13. Now, that's the correct answer. If you got to the 10 to the 12, 1.23, you got most of the distance. Just need to finish it out slightly different, okay? There's something there to learn, so don't let it discourage you. Errors are a great thing. I learn more by mistakes I make than getting it right. When I get it right, I'm like, yeah, that's not too bad. And then when I try to do that shit 3 days later on a test, I did it once, and I don't know what the fuck I'm doing. I have no clue. I did the problem once. If I got it wrong and I kept having to do problems till I got it right, I got a lot of practice. When I got to the test, I was able to do it. So, when you're doing your homework or doing this stuff in here, if you get it wrong, that's a good thing. Okay? Don't be discouraged by it. It is, seriously is. In fact, if it comes so easy to you the whole way, you get fucked when it doesn't, because you don't develop good habits. You've never been knocked down by a wrong answer, so you're like, I don't know what to do. You like people that are great eventually hit like where it comes naturally. That's what I mean by great. When it comes naturally, you get to a point where it doesn't come naturally, and you don't have the skills in place to keep going. You've never had failure, so you're like, I don't know how to deal with it. Keep going, keep trying. Let's look at division. Before we add in like the numbers, multiply it, it looks like the real kicker on this is what's happening with that 10 to the exponent thing. So like, let's look at an example. If we had like 10 to the 6th power over 10 to the 4th power. Ten to the 6th power is a 1 followed by 6 zeros. And 10 to the 4th power is a 1 followed by 4 zeros. And if I don't know what to do with that, I can always put it in the calculator. $100, which is 10 to the 2nd power. Is there a relationship between the exponents here? And if so, what is it?
Subtraction.
It's subtraction, right? 2 is 6 minus 4. So the rule here is 10 to the m power over 10 to the n power is going to become 10 to the m minus n. We're going to use that in a second. I realize I should go over something that we had on the back one right here. Let's take a look at this, and what would I do in a calculator to do this? Because let's face it, how much do you want to do this by hand, right? If I can do this in the calculator gives me the answer. Let's do that. Well, this 10 to the something usually shows up on a calculator. On my calculator, I don't know if you can see it, if it comes in very well. Shit. It's right above the log button, LOG. There's a 10 to the X. There's a 10 to the X right above it. And it's in yellow writing, and the shift key is in yellow. So if I want to access 10 to the X, I hit the shift and then the log. So what I'm going to do, if I wanted to do this problem right here, I want the glare right on it like that. I'm going to say 3, and then I don't need to do the X. I can just do shift 10X 5. That is my 3 times 10 to the 5th. And then I go times 4.1 And I do it again, shift 10x, and this was 7. And they give me the answer is 1.23 times 10 to the 13th directly. Okay? So if you've got a calculator and you learn how to use that 10 to the x button, this will work good. You can put the x in there. I can say 3 times shift 10 to the 5, then times 4.1 shift 10 to the 7. I didn't do it again. Let's put the times in. Times shift 10, oops, yeah, 7. And it should still give me the same thing. So you can have the x in there or not. But if you learn how to do it in a calculator, you can speed this up and make sure you get it right. Let's face it, how much are you going to be doing this in real life? Not a lot. But I do need to show you how to do it, and then I think knowing how to do it on the calculator helps. That was that. Let's get back to the dividing. You can do the same thing with the calculator on dividing. But I think it helps to know when you're looking at what's going on. So if we had, say, 3.14, or yeah, 3.14 times 10 to the 7th, divided by, let's go with 2 times 10 to the 3rd. We can break this one up like this. So we can do 3.14 over 2 times 10 to the 7th over 10 to the 3rd. And 3.14 divided by 2 is 1.57. And if I do the subtracting thing here, I have 7 minus 3 is 4. This is times 10 to the 4th. And my decimal is already in a good spot. There's only one number in front of it, so that would be where I'd stop. If you're going to do this in the calculator, I recommend doing just the numbers first, hitting equals, and then doing the other part first. I recommend going 3.14 divided by 2 equals, and then I'm going to say times shift 10 to the 7 divided by shift 10 to the 3. Oh, I didn't write it in scientific notation, you bastards. Well, it gave me 15,700, but I know how to convert that to scientific notation. It's a big number, and we moved it left 4. So move left 4, big number, positive exponent. I'm sure there's some way to get it to always show in scientific notation. That's annoying. You don't want that. Any questions? Something quick to point out for you. This is 7.5 over 1.5 times 10 to the 4th power over 10 to the negative 3 power. And so when we do it, 7.5 divided by 1.5 is 5. And this should be times 10 to the 4 minus negative 3. And we haven't really talked about minus and negative in this class. What do you do when you have minus and negative? Let's take a look in the calculator what happens. If I say 4 minus, can I do minus 3? It gives me 7. So 2 negatives become a plus. So this would be 5 times 10 to the 7th. Ready for another topic? Okay, we're going to talk about the intersection or union of sets. This actually, the ideas here show up a lot in the probability chapter. So I'm going to explain to you what the notation means and how it's read. Let me just start with an example though. I'm going to have a set of people A equals, let's say we got Maria and we got Jared. And we got, let's put, what?
Could you read the paper down?
Yes, I can. Thank you for letting me know. I got Maria and I got Jared and I got Maddie and I got Arturo. And I got, well, we got Hefe, we got David. David's in here. And if I have set B, let's put Tyler in there. Let's throw Cody in there. Let's put Selena, Jeanette. And let's put David in there again. I got 2 classes. I chose names from both of my classes to kind of mix them up. So some of your names are in set A and some of your names are in set B. And same with my morning class. I got some people in there from set A and set B. So there's 2 ideas here. Let's start with intersection. Where does set A intersect set B? What this really is asking is, what do they have in common? Or what is in both sets? The notation they use for intersection is a big fat upside down U. And so this question is written shorthand notation as where does A intersect B? That's the shorthand notation for that question. And so like a handy way of looking at this is what is in A and B? And what is in both? Well, if I go down the list of names, if I look at the top, or if I look at the, let's go at the second set. Is Tyler in the top set? No, he's not. Is Cody in the top set? No, he's not. Is Selena in the top set? No. Is Jeanette in the top set? No. Is David in the top set? Yes. So that's how you're going to like go through and figure out what the intersection is. The intersection is just David. Now, if I wasn't in the second set, we would have had A intersect B equals, and we put nothing inside the braces. These braces represent set. Another way to write empty braces is you put a 0 with a line through it. This is the symbol for empty set. And that's what that is. A set with nothing in it is an empty set. But you don't put the empty set symbol into the brackets or the braces. Ah, butt hurts. Okay. We can also do the question, what is the union of A and B? The symbol that's used for this is a U that's vertical, but it's wide. And we would write A union B. It's wider than a normal capital U. And what this means is what is in A or B. And the or here is the important word here. So when we're doing it, you can write all of the elements or the members of one set. So I got Maria, I got Jared, I got Maddie, I got Arturo, I have David. And now I will add all the people that are in B that aren't already listed. I also have Tyler, Cody, Selena, Jeanette, and I would put David, but I already have David, so I don't need to put it again. David is an overlap here. Don't put him twice. This idea transfers over to chapter 5 when you're doing the probabilities stuff too. And I will give you an example. Does anyone need this page up longer? Okay. So quick recap. A union B is A or B. So it's what's in both. What's in either, I should say. A intersect B is A and B, and it needs to be in both. What's in both sets? Has everyone here seen a deck of cards? Playing cards, not like Pokemon. Regular playing cards. Whether or not you play with them or not is a different question of knowing and having seen them. They have your aces, your king, your queen, your jack, stuff like that. A deck of cards has 4 suits, hearts, diamonds, clubs, and spades. And the spade is like that. And these look like more rounded balls, so I'm gonna make that look a little bit more rounded. And the hearts and diamonds are red. It also has 13 ranks. We have ace, or the A, which is like basically the 1. And then we've got 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 of them. The last 3 rings are the jack, the queen, the king. Jack, queen, king. These all have pictures on them, so these are all called the face cards. There's faces on them, so we call them the face cards. When you're going through the homework, you're gonna have stuff like this. In the stats homework, the regular class, you'll get like questions like this. How many cards are, well, they'll have it more as a probability, but you're gonna have to do this. How many cards are a queen or a heart? This is the probability of queen, union, heart. Well, we have the queen of diamonds, we have the queen of hearts, we have the queen of clubs, we have the queen of spades. That's all the queens, there's 4 queens. And then we have the ace through 10 of hearts. We have the jack of hearts. We've already done the queen of hearts, so I don't need to do it again. And we have the king of hearts. There's 4 here. And there's 12 cards listed here, which is a total of 16. One way of looking at doing this is just the quick way is going, how many hearts, how many queens, and then the queen of hearts shows up in both. So let's subtract -1 queen of heart. There's 13 hearts plus 4 queens, -1 queen of hearts would give us 16. But unless I subtract that queen of hearts because it shows up twice, I would get 17. You'll also see in the homework, they'll do something like this. How many are queen and heart? Or queen intersect heart? Well, there's only one. It's that one right there. There's just one, the queen of hearts. So these types of things are going to show up in the probability section. Do you guys have any questions? Would you like to get the fuck out of here? Say it, Maddie, say it. I want to, you don't have to cuss if you don't want to. Do you want to get out of here?
Yes.
You're free to get out of here. Have a good day, guys. Have a good weekend. She's like, hell no, I ain't saying you might show this shit to my parents. I only cuss when they're not around